Good morning, Algebra 2 honors over the summer class. It is Kevin Shorbley, and I am here to present my linear programming project as IT Solutions Incorporated. What do we offer? We offer IT solutions for small businesses and small enterprises for a cheap price. We charge at a monthly rate with networking and technology support included. We offer switches and desktops. We are trying to make the most hardware for companies. Our objection function is x plus y equals z because we want to give you the most bang for your buck. Switches are going to be represented as x and desktops are going to be represented as y. Here are our constraints. Since we are charging monthly, we have a maximum budget of $5,000 on hardware that we spend and a minimum budget of $1,000. Each company must have one server. We can represent this as x is greater than or equal to 1, a budget of $5,000 as we've previously stated, and we can represent this as 500x plus 300y is less than or equal to 5,000. This is because servers cost $500 and desktops cost $300 MSRP. And since you must spend at least $1,000, we represent this graph as 500x plus 300y is greater than or equal to 1,000. And we have to do this because you must have at the least 0 desktops, so this can be represented as y is greater than or equal to 0. Here are our graphs and our min-max points. So here is our nicely drawn out graph. This is our x is greater than or equal to 1 line, as you can see. And this represented for the solution set will be the horizontal lines going across right here. The y is greater than 0 line is right here, greater than or equal to 0, my bad, right here. And this is represented by the vertical lines right here. And the 500x plus 300y is greater than or equal to 0 is represented as the circles, as you can see right here, all the circles. And the 500x plus 300y is less than or equal to 5,000 is represented by our dots right here, as you can see. Our min-max points are as follows: 1, 15, 1, 5/3, 2, 0, and 10, 0. Here is a graph that we made on Desmos to make it easier to see where our min-max points are, as you can clearly see right here. And here is how we got our intercepts for this graph right here. As you can clearly see, we plugged in 0 for y, to get our x's right there and there. And we plugged in 0 for our x to get our y's, as you can see from this one and this one. Here is our calculations. We found that 500x plus 300y is greater than or equal to 1,000, and 500x plus 300y is less than or equal to 5,000 are parallel, meaning they never meet. This being said, we know that they will not form a vertex, so this is why you will not find work included with both of these, because they are parallel and they never meet, obviously. Here is our math of knowing where to shade. So for y is greater than or equal to 0 graph, we see that 1 is greater than or equal to 0. For our x is greater than or equal to 1, we plugged in 2, got 2 is greater than or equal to 1, so we shaded that area. And for this one, we saw that 0, plug in 0, 0, we saw that 0 is not greater than or equal to 1,000, so we shaded in everything that doesn't include the solution set 0, 0. and 500x plus 300y is less than or equal to 5,000. We plugged in 0, 0 once again, and we found out that 0 is less than 5,000, so we shade all the area with 0. Here is how we calculated our vertices. Here is the vertices with the x is greater than or equal to 1, and the 500x plus 300y is less than 5,000, and here is the y for that. And here is the x is greater than or equal to 1, and the 500x plus 300y is greater than or equal to 1,000, and the y is greater than or equal to 0. Variant for it. Sorry. Evaluating, and here is how we evaluated our vertices in our objective function, so how we know what will get you the most amount. And we found that with all these calculations, that this one right here is the most hardware for the bang for your buck. So we can see this as 1 in 15. Thank you for listening, and I hope you have a nice day and invest in my company.